everyone. Good morning, good evening, good afternoon. My name is Swagata Ashwini, and I'm really excited today to share insights on a very interesting topic. So, I'm going to talk about customizing GPT models for domain specific NLP tasks. And I'll also delve deep into techniques that you can use to facilitate fine tuning and adapt to your own specialized field or task. So, moving on, I just wanted to introduce myself before we dive into the agenda for today. So, I'm Swagata Ashwini. I work as a principal data scientist with Bhumi. For those of you who are not aware, we are an iPaaS leader. I am in charge of deploying AI solutions for the company. I lead a team of data scientists who work together from India as well as US. We focus a lot on NLP based solutions. Apart from my work, I also spend a lot of my time in doing AI research and also an advocate for women in tech. I absolutely believe in giving back to the community, so I regularly contribute to open source initiatives, again, as well as contributing to women in tech and advocating for those initiatives. Feel free to connect with me on LinkedIn or Medium. I would love to hear from you. And if you have any questions or doubts beyond this presentation, I would love to collaborate. So, moving to today's agenda. So, today we will embark and start on our journey with introduction to GPT models. And I'm sure a lot of you are already aware of it with the latest AI buzz on generative AI and chat GPT. This is a very growing sector of AI. So we'll first talk about introduction to GPT models and kind of understand their importance and history of how it evolved to where it is with GPT-4. We'll also then look into some domain specific customization and understand the importance, like why we actually need in what scenarios and why it's important. And then we'll move on to some fine tuning techniques theoretically. So I'll talk about some of the fine tuning techniques, and then we'll talk about the challenges and pitfalls for these fine tuning techniques. And towards the end, we'll focus on a code walkthrough where we'll see applying one of these fine tuning techniques and see how that improves our performance for our specialized task or use case. I'll save the last 5 minutes for any questions and anything that you have might have. So moving on. So introduction to GPT models. So GPT, like I said, has been the buzzword for a while. GPT is basically generative pre-trained transformers, and these models basically are trained on a large corpus of text data. And because they have been trained on such large amount of data, they have the capability to generate text that is contextually extremely relevant to input prompts. So coming to the history of GPT, it first started with GPT-1, and GPT-1 had interestingly only 117 million parameters. And the evolution to GPT-4 has been significant because now GPT-4 has um, substantially more number of parameters, almost equivalent to 45 gigabytes of training data, as opposed to GPT-3, which has 17 gigabytes of data. So obviously, when we compare GPT-3, GPT-4, we can say that GPT-4 can provide significantly more accurate and contextual results compared to GPT-3. And when it comes to the capabilities of these models, they are quite capable in terms of writing, essays or songs, even creating summaries and poetry and whatnot. Basically, any question answering engine, it can answer anything that you want to ask. Moving on to the importance of domain specific customization. So, what is domain specific customization? So, essentially, the GPT models have been trained on a large amount of data, but that data is primarily pertaining to a particular language, for example, English, and the data would be very generic. It's trained on the general data that is available on the internet. But when it comes to creating something which is domain specific, for example, if you're working for a medical company or a legal company, or you're working on any of those use cases, the customization comes into play, because there could be, first of all, some terminologies that are not present in the general train data, and you want to fine tune it with these particular new terms that are particular to your domain, so that the model can understand that these terminologies are important and relevant to your use case. So customization can also, drastically reduce errors and improve the accuracy for predictions in these case of specialized tasks. So most commonly in medical, legal, or even financial sectors, you'll see a lot of customization being applied and fine tuning being done to all these GPT models. Okay, so now if we look at some of the fine tuning techniques, the first one that is most common is supervised fine tuning. So, supervised, as the name suggests, is basically a technique where we are using a labeled data set to guide the model towards learning the specific nuances of our domain. So, this approach is essential as it serves as a foundational step in narrowing the model's focus from a very broad understanding to a very domain specific perspective. So, how do we do it? We initiate the process with an already pre trained GPT model, and we train it further with our own label data set. And this additional training allows the model to specialize in our chosen domain, and therefore it will enhance the performance and improve the accuracy of the new fine tuned model. So, this is the first technique. The second technique of fine tuning is few shot learning. So, few shot learning is a very interesting concept where it involves training the model with very few or limited set of examples. The few shots are basically prompts or examples that we provide to guide the model in generating desired outputs. So, this technique is very handy when we have very limited label data. So, in few shot learning, we provide a series of examples in the prompt, including example one, example two, like that, and we guide the model to understand the pattern and kind of the response that is expected. So we can guide the model and say, like, see, this is example one and this is the type of result I expect, and give the model couple of examples like that, so that it can learn the pattern and be able to predict in future examples as well. There is although one challenge with this approach, although it's very powerful, because only with few examples you can guide the model, but it can be inconsistent and might require very careful crafting of prompts. But with the right approach, it allows the model to quickly adapt to new tasks with very limited data. Moving on to the next technique. This is a familiar technique we have used in machine learning and deep learning tasks as well. So, hyperparameter tuning basically involves tuning or optimizing the parameters that govern the training process, but nothing to do with the training data. So, for example, there are parameters like learning rate, which basically dictates the step size during optimization, and there is batch size, which refers to the number of training examples to be used in one iteration, and so on. So these parameters ensure that the training is efficient, and in return it obviously makes issues such as overfitting and underfitting, helps them avoid such issues, because the training is done in an efficient manner and you're choosing the optimal parameters so that the model is trained in the right way and does not lead to any overfitting or underfitting, and eventually creates a very generic robust model. Moving to the next technique is called zero shot learning. So, as the name suggests, zero shot learning, basically the model is expected to perform tasks for which it has basically not seen any example during the training. So it leverages the knowledge that it learned during the pre-training to understand and respond to tasks or prompt that it hasn't been explicitly trained on. So an example could be a text classification problem where the model is asked to classify text into categories that it has not even been seen or trained on, but it's supposed to use its own understanding based on the pre-trained data. It's a very interesting area of research and very powerful. So, moving on to our last fine tuning technique, and again, this is a familiar concept in machine learning and deep learning, which is regularization techniques. So, regularization techniques are mostly used to prevent overfitting, and it helps the model to generalize well on unseen data. So, we employ a couple of techniques like dropout, which basically means you're selecting random neurons and you're ignoring them during the training so that the model becomes more and more robust. And another technique is layer normalization, where you are normalizing the inputs across the features, and hence you're basically stabilizing the entire learning process. So these are some of the regularization technique that can be used. The benefits of using these techniques is it ensures that the model does not memorize the data or kind of overfit, but actually understands and learns the underlying patterns. So hence it can perform well on unseen data as well. Okay, so having gone through all of these different fine tuning techniques, now we will see that what are basically the challenges and pitfalls with these fine tuning techniques. So the first one is data bias. So of course, when you're adding data and you're fine tuning your existing model, the data that you add has to be very generic and should not have any um, undersampled or oversampled categories or have some sort of bias, whether it could be sampling bias where some of the classes are underrepresented or overrepresented, or there could be a prejudice bias where there could be some stereotypes that are coming from the data it's trained on. So it's important that the data that we add for fine tuning should make sure it doesn't have any of those biases. The next challenge is overfitting. So overfitting again is a phenomena, like we all know. It's basically memorizing the model, memorizing the training data, and it cannot perform well on unseen data. It will perform well on your training data, but it cannot generalize the model. So basically it's learning the noise and specificalities of the training data rather than learning the underlying pattern of the data of the model. So as a consequence of overfitting, it will perform well during training, but it will drop significantly when it comes to new data or unseen data. So to prevent this, again, like we discussed, there are a couple of methods, including regularization techniques or cross validation. So those are some things that we can deploy to avoid this situation. The last challenge or pitfall is resource constraint. So when we are fine tuning models like GPT-3 or GPT-4, of course, these are extremely big models and that require substantial computational resources and memory. So these resources can sometimes be very expensive and limit the ability to fine tune the models adequately. So to overcome these constraints, we can resort to techniques such as transfer learning, where we leverage the pre-trained models to reduce the computational needs, but we also can use cloud-based solutions that can offer scalable resources to accommodate our computational needs. Um, so now, having understood the different types of fine tuning and the challenges, we can go over a notebook or a Google Colab notebook, which has been given by OpenAI, that we can walk through and understand how fine tuning is done. And for this demo, we are going to use a supervised tuning method that we discussed, wherein we are using a pre-trained model, and then to fine tune it, we add our own data set with the labeled data so that we can fine tune and improve the performance of the model. So I am going to be sharing this link with all of you after the presentation. So whenever you need to run or fine tune or do any experiments with any models by OpenAI, the first thing is you need to go to OpenAI and create your OpenAI API key. And once you create that, you can use that for making API calls and getting response from these models. So going over the notebook, we first import the essential libraries, and then we kind of give our own access key. And we in this particular code section, we are getting a PDF file, and feel free to change this, and if you want to use some other data set for your own use case. Now this PDF has around a lot of material, but we are going to fetch 40 questions from this PDF that will be our training data. So after we get this PDF file, we are going to generate those 40 questions that we need for our training. So here, after this cell, we have basically generated our training data that we are going to use. Now, in order to test this, we are going to create another separate data set, which is going to be our evaluation data set. So we train on one and then we evaluate on unseen data just to see how the model is performing. So now we have created a training set and a evaluation set. So first step would be that we want to see whether the model is performing well with no fine tuning at all. So here we are going to use the GPT 3.5 model as is, and we're going to evaluate on our evaluation data and see what is the performance of the model without any fine tuning. For this use case, there are two metrics that we are going to use. One is answer relevancy and faithfulness. Answer relevancy, as the name suggests, basically measures how relevant your generated answer is compared to the prompt. It will give a value between 0 and 1. The higher, the better. Faithfulness is an interesting metric wherein which it tells like how consistent is your answer given a context. And the more contextual information you give in your answer, the better the faithfulness score would be. And again, it's going to be between 0 and 1, and higher the better. So now in the next few cells, we are calling the GPT 3.5 model and getting running our evaluation test and getting those metric results. So like you can see here, the scores that we got for answer relevance and faithfulness are pretty good, 0.97 and 0.76 respectively. Now let's see, when we fine tune our data, do these metrics improve or not. So for generating some additional data that we can create for fine tuning, there are two ways. In this example, they have used GPT-4 to collect training data, but we can simply use another file and append it rather than creating it like this. So in this example, we are using GPT-4 to collect and create additional training data that we will append and fine tune. So here we are adding those to the train questions, the original 40 questions that we had, and we are appending the newly generated data in this. Now, in order to create the fine-tuned data, there are specific format requirements. So when you're fine-tuning, you're supposed to append the file or any new data that you have in this .jsonl file. So that's what we are doing here. So now we have 61 examples. So initially we started with 40, and after the creation of additional data, we are adding more examples. So now we have 61 total examples that we have fine-tuned. Now we are running the fine-tune job. Basically, we are running the script that will update the training, and again call the GPT 3.5 model to validate how is the get those additional metrics. So here we are testing on the evaluation data set, the same test we did before with the GPT 3.5 model, but this time we are doing it with the updated fine-tuned data set. So now if you see the result, the answer relevance is pretty much the same, but the faithfulness has increased. So you can see just by adding a few more examples and fine-tuning our data, the metric has increased. So now let's just see with an example, like what was the question and what was the answer before without the fine tuning and what was the answer after the fine tuning. So let's take an example of this question. What is a key barrier globally for ocean health, governance, and adaptation to climate change according to the report? So when we use the original GPT 3.5 model without any fine tuning, the response that we get is, according to the report, a key barrier globally for ocean health, governance, and adaptation to climate change is availability of technology, knowledge, financial support, as well as existing governance structures. Seems pretty accurate. Now, when we move to the fine tuned version and see what is the output for the same question, you can see that the output is pretty much more descriptive and has a lot more contextual response added to it, which is why the faithfulness score that we have increased significantly from 0.76 to 0.80. So we can see that how powerful fine tuning can be. With just 21 more examples, we were able to improve the faithfulness to decent amount. So imagine what you can do with a bigger data set, and we can have more metrics than this, and fine tuning can really be a big advantage in those scenarios. So that was all for this presentation. To conclude, I just want to say that today was a brief session where we went over GPT models, looked into the history and evolution of GPT models, and learned some fine tuning techniques theoretically, and understood the challenges that come with these fine tuning techniques. And finally, we did a walkthrough of code where we are looking at a fine tuning examples and seeing how fine tuning can improve the metrics or model performance. And I would love to leave the last few minutes for any questions and anything that you would like to ask or discuss. And thank you for your time and engagement today. I hope the session was insightful, and feel free to reach out to me for anything related to this or even anything that you would like to collaborate and discuss on. Thank you.